What's up, you data friends? It's Yanis here and welcome to my channel. In this video, we are going to go over a Python test example for interviews, and more specifically, this is going to be a junior level test. Over here, we have 6 questions that we need to answer in under 20 minutes. So it's about 3 minutes plus per question. So down here, I have all the questions answered, but what I suggest that you should do is that you should download this file from my GitHub page, come over here and attempt to answer these questions yourself before you watch this video and see how well you've done. And before we start this video, let me just say that if you're passionate about data analytics and data science, then please consider liking this video, subscribing to my channel, and enable notifications for my future videos. Right, starting with the raw data we are going to use. Over here, we have 3 files. We have the car main, which has this information about the cars. Let me quickly run it. And let me run the other 2 so you can visualize them. We also have the car info that has some additional information about these cars. And as you can see straight away, we have index, which is going to be our key column we are going to use to join these files together. And then we also have another file, which is the car use prices. So if we visualize this quickly, this has just the index and the use price of the car. Now, in your Python test, most probably they're either going to give you the raw data in the form of Excel files. So you're going to need to know how to run these to load your data in DataFrames, or they're going to already have the data loaded in the UI they are using, and you're going to have to start answering the questions straight away, like we do down here. We don't load them, we just start answering the questions, but they are already loaded from the code before. Right, starting with the first question, it says, what is the total retail price per make? And as we can see from our main data, we have retail price over here, and we also have make over here. So we want to aggregate retail price by make. So what I'm going to do is that I'm going to select my data frame, do dot group by, open brackets, into group by. I want to add our make. There we go. And then I want to say dot as index equals false, because I don't want this to be a new index, and then dot agg over here. I want to select retail price, so I need to open these brackets too, and then like this, retail price, and this is the total, so this is going to be a sum, like this. Click enter. There we go. We have the sum of retail price per make. We can also showcase that we know how to sort our data, and it's always good to showcase more than what the question is asking you. So we can actually say dot sort by use by retail price, like this, and then comma ascending equals false, because we don't want the data to be ascending, like this, close brackets, click enter. Ascending to ends, click enter again, sorry, like this. There we go. So we can see that Ford has the most sum of retail price cars, then Mercedes, Bentley, Audi, etc., etc. Right, moving on to the second question. It says, which model has the highest invoice price combined for 2023 and 2024? So now we have to use invoice price and also model. However, I have noticed that invoice price column is already clean, which is not the case with the original. Invoice price should have had the $sign and the comma. However, because I have already run the answers, it already cleaned the data frame. So I'm going to rerun the loading the data. So there we go. And if I come down here again quickly, visualize. There we go. Because the question is also trying to test if you know how to clean the data. So I want you to be able to go through that to do the aggregation straight away. So yeah, this is from where we start. The first thing you're going to see is that invoice price is not actually a number like retail price. It has the $sign and the comma. So first we have to clean invoice price, and then we need to aggregate it by summing the invoice price by model for 2023 and 2024. If we quickly check the data types, so you can see that it's not a number, the types, click enter, you can see that invoice price is an object. So if we attempt to do the aggregation, so let's say if we did invoice price over here, this was going to throw an error because, and this one, like this is throwing an error because it says I cannot aggregate a string column, so an object, for example. Let me unhide quickly. Sorry, go back, click run. So the first thing I'm going to do is that I'm going to select the invoice price, copy, paste, and then clean it. So I'm going to do equals.str.replace, and I'm going to replace the dollar value with empty. Where is the dollar sign? It's over here, like this. And then I'm going to rerun this once more to replace the comma with empty. And down here I can say dot as type, and I'm going to set it as float. So now it's a number. So if we check now, rerun the card.head, you can see that we have our column clean. So now we can apply aggregations. And the aggregations, I'm going to copy this code, come down here, paste it. I'm going to switch the make with model because we want the model now. So I'm going to copy model, add model. I need to add a condition, which is the year to be 2023 and 2024. So actually over here, I need the condition of year, like this, and then in, year, where is it? In, and then over here, I need to say 2023, 2024. I think it's like this. Sorry, it's not in. In is actually in SQL. It has to be .is in, and then open brackets. Sorry, is in here. It's open. Yeah, that's fine. Group by model. That's correct. Sum the invoice price. So now we have to sum the invoice price in the aggregation, and we can also, let's not sort it for now. We're going to sort it later. And let's run this, see if it works. There we go. So now we have all the models, the sum of invoice price, the clean invoice price for the years 2023 and 2024. 2024, as you can see from here, and we also have 2023 included. And the last thing we can do is to sort the data by. Again, we are showcasing that we know more Python, and you can see that the model with the most invoice price, combined invoice price, is this F.350 Super Duty. So which model has the highest invoice? Yeah, we can actually do .top one, .head, and then select the first. And this is completely answering our question. Right, moving on to the next question. It says, show the average retail price per make, retail price, we don't need this, retail price per make for all four-wheel drive cars. And it's actually specifying the column that we have to use is drivetrain. If we check our main dataset now, we can see that we do not have drivetrain. So if we check the second data frame we have, quickly, there we go. So we can see we have drivetrain in our second dataset. So we have to use our second dataset to somehow filter our first dataset. This is what the question is asking us to do. So the first thing we're going to do is that we are going to create a list with all the four-wheel drive cars. So I'm going to say four-wheel drive cars equals, and then from this dataset, the second dataset, I am going to select all the cars, and in our case, it's going to be all the indexes because each index is a car in the first table. I'm going to select all indexes where drivetrain equals four-wheel drive. So I'm going to copy index, come down here, I'm going to add index in here. And then four-wheel drive cars equals, get this, where, copy this, paste it, equals, and then this is going to be drivetrain, like this, equals four-wheel drive cars. So let's test this list, see if it works. No, it didn't. It gave us an error on index. Oh, it's because I'm not using the name of our table. I'm just using the name of the list. Sorry. So car info from here, and then run. There we go. We have an index, or sorry, we have a list with all the indexes / cars that are 4-wheel drive. The next thing we need to do now is to show the average retail price per make. So I'm just going to copy the code we have, let's say above here, up until before the sort by use. Copy, paste it down here on the third question. I want to group by the data by make. That's correct. I also need to condition my data to only select the 4-wheel drive cars. So I'm going to do this. I want to say where index dot is in open close brackets and pass my list. So the first bit is filtering all 4-wheel drive cars from the second data frame into the first data frame, and then I'm grouping the data by make. That's correct. And now I need the average retail price. So I'm going to say mean over here, not the sum, like this. Click run. There we go. We have the average retail price for 4-wheel drive cars. We can also sort the data. So again, showcasing that we know how to run more Python like this. Click run. We need the retail price, not the invoice price. Click run. There we go. We have successfully answered the question. Right, moving on to our fourth question. It says, show the minimum and maximum use prices per make where the year is 2024. So if we check our dataset now, you can see that we do not have use prices. It's actually in this third data frame, use prices. So if we visualize it quickly, copy paste head and then visualize it. This is the column we want to get the minimum, the maximum by make. So basically we need to run a join. This is what the question is asking us. So I'm going to come down here. I'm going to say join one, let's say equals. I need to join my first data set, which is the car data with dot merge, open brackets, sorry, merge. The third data frame, which is the car use prices. So basically we are going to put this column, the use prices, into our first data frame over here. So we can then aggregate it, use min and max. Down here, I'm going to say how equals, we're going to use a left join, left, and then we are going to join on the index, because as we said, index is the key column. So index, sorry, like this, then close brackets, then let's visualize our join to see if it worked. Copy, paste, dot head. There we go. So now we also have use prices. So now we want to show the min and the max, and in order to do this we have to create another column, because in Python when you are aggregating the column it actually replaces the column itself. So what I'm going to do is that I'm going to copy this. I'm going to create a new column called let's say use prices max. Use price max, like this, and then this is going to be equals to our existing column, which is going to be the use price. I'm just creating a copy of the column now. That's all I'm doing. You can see it's just a copy before I aggregate it. Then I want to condition my join one to only have data for 2024. So over here I need to say year equals and then 2024, sorry, like this. And now I need to group my data by, so group by open close brackets. I need to have make in here because we need it by make. So I'm going to copy make like this. I'm going to say comma as index. I'm going to say this is false. And then I need to do an aggregation. What do I need? The mean and the max. So I'm going to copy this quickly. An aggregation. I need the minimum use price. So I'm going to do use price like this. This is going to be the mean, like like this. I'm going to add a comma over here, and I need another aggregation. You see, this is why I created the copy column, because Python replaces. So I'm going to use this column now, and this is going to be the max by make. That's correct. Let's run it. There we go. It works. Let's order it. Let's do the sort values. Yeah, like this. Oh, we cannot sort them because we have two. Yeah, I'm not going to sort them because we have two aggregations. What we can do though is that we can pass this back into join, and we can rename the columns. So we can say dot columns. So again, we are showcasing that we know how to do Python. So what do we need? We need the make. We need the use price. Sorry, make. We need the. This is actually the minimum use price. So we can do like this, and then the maximum is already renamed, which is good. So if we copy this, paste it, what we can do is that we can remove the nulls, because Mercedes-Benz and Nissan do not have a use price. So we can do over here .drop NA, for example. Click run. Oh, we also need to visualize it. Copy, paste. Yeah, there we go. So we have a nice clean answer that has the make, the minimum use price, the maximum use price for 2024. Right, moving on to our next question. It says, show the model with the lowest highway fuel economy. And if we check our raw data now, we can see that highway fuel economy column comes from our second table. And it's actually not a number, it's actually a text. So we have to clean highway fuel economy first. Then we have to create a list, let's say, with the indexes / cars that have the lowest highway fuel economy, and then filter that list from our main table so we can get the make. Right, so I'm gonna select our column, so highway fuel economy quickly, so we can start cleaning it, which is gonna be in here, highway fuel economy. It comes from the second table, which is this one, car info. Come down here. Actually, let's visualize it so we see what we are doing. Like this. Yeah, we need the first two characters. So highway fuel economy, let's say NO. So creating a new column. So the number equals with the highway fuel economy .str. And then I want to take the first two characters. So let's check it like this, like this. Oh, there we go. It worked. And then we can do .astype and then set this to a number so we can aggregate it. Run it again. There we go. It works. Now I want to create the list with the cars / indexes that have the lowest highway fuel economy. To do this, I need to say lowest and then highway fuel economy maybe equals, I want to select the index from our table where, and then in our condition, I want to say where the highway fuel economy NO equals with the highway fuel economy NO dot min, so the minimum value. And then if we test this, I cannot do it because sorry, we need a double. Equals, yeah, we need a double here. There we go. So we get a list with 1, 2, 3, 4, 5 indexes. So these are the 5 cars. So now we're going to come back to our first table, which is the car data. And we are going to say select everything from car data where the index dot is in open close brackets, and then pass this list. And then if we run this, we get an error, and the error is because index is spelled wrong and we need 1e. There we go. So we have these 5 cars now. And all these 5 cars have a highway fuel economy of, we don't know because we haven't joined it. However, the answer is correct. These are the models. It's asking for the models. but we can actually visualize them either from our second table or we can run a join. Now I'm not going to run a join, I'm just going to visualize them quickly. So I'm going to copy this, paste it, and then I'm going to replace card data with card info, and I want the index to be in that index. There we go. So these are the cars. So we can see they are pretty much all electric, and this is why their highway fuel economy is the lowest. Right, then we have basically answered the question that is asking us to show the models with the lowest highway fuel economy. Now, going down to the last question, it says create a new column that has the retail price category, of the car with the following, and it's giving us the three categories we want to create. Is cars with a retail price less than 50k, between 50 and 100, and more than 100. So now we are going to create a new column which we are going to name as retail price category. So I'm going to copy and paste it, retail price category equals, and I'm going to say np.where, and over here we're going to add our conditions. So the first condition is going to be where the retail price, let me copy the column from somewhere, invoice price, where do we have, we don't have retail price, anywhere. Anyway, I'm going to copy it from here. I'm going to say where the retail price from car info, like this, is less than 15k, 1, 2, 3, then I want to have this category. There we go. Next, I want to open another np.where. So I'm going to say np.where up until here, np.where the retail price is less than 100k now, 1, 2, 3. Then I want to give it this category, 50 to 100k. Otherwise, comma, it's going to be more. So I'm going to give it the last option we have, which is more than 100k. Then we need one. We need another one, I think. Did it close? Another one. Sorry, two. We don't need the third. Click enter. But first, let's visualize. No, sorry, not from car info. It's from car data. Good thing we noticed it was going to fail. There we go. Click run, and let's check our new category. We have it twice because I have actually run. Sorry, let me rerun the data loading, which is this one. There we go. Sorry, because I have already run the answers above, that's why they show up. We should only have one. There we go, one. So let's check if it's correct. The first car over here has a retail price of 242k, which is more than 100k, which is correct. These ones, they have less than 50k, and then this one has between 1500. Yeah, it's correct. So we have successfully answered our last question. Right, so this is it for this video. I know we took more than 20 minutes to answer all the questions, but it's because I was trying to explain them as I was doing it. Let me know in the comments below how you found this test, if it was too easy or if it was difficult for you. If you want something more easy, you can check my previous video, which is a beginner level test. And if you want something more difficult, I'm going to be uploading more tests, an intermediate test and a difficult test, so you can test your Python knowledge. Right. So I hope you've enjoyed this video and you've gained enough value out of this video. If you feel like you did, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Thank you very much for watching, and I'm going to see you in the next video.